Alright, aloha. This is just going to be a quick intro to Unit 5 on polynomials. So we're going to do a quick recap. We're going to recall PEMDAS and like terms, and then I just wanted to really quickly talk about the order and the commutative property. And this is something that we mentioned in class before. The commutative property is saying that you can rearrange the terms if you want to. Like 3 plus 2 is the same thing as 2 plus 3. The other thing you got to be worried about is keeping the signs with it. And the sign is always going to be the number, or is always going to be the thing in front of the number. So like if you have like 5 minus 10, you can rewrite that as negative 10 plus 5. So here, this 10 is negative, and here, this 5 is actually positive. So if there is no sign, it's assumed to be positive if it's out front like that. So if you want to rearrange, you just got to make sure that you keep the signs with it the same. 10 is negative, 5 is positive there. And then moving ahead with polynomials, we're going to be doing all these things to them. We're going to be adding, subtracting, multiplying them. We're going to be graphing them, and we're going to be factoring and doing some word problem application problems with them. So polynomial, poly means many, and nomial means terms. So we're dealing with many terms. That's what that kind of translates out to, many terms. So this is from a worksheet that we did at the beginning of class, like day 2 or day 3 or something like that. It talks about the 2 major objectives in math class. So if you got that sheet, it's always good to have it out. Targets 20 or 18 and 19 and 20, and a lot of them are going to be focusing more on simplifying expressions. So our mission is to combine like terms and reduce each term. Here we got an example that we walk through in class, 5x and negative 8x. These guys are like terms because they both have an x. These fractions, 1/2 and 5/8, are both like terms because they don't have any variables at all. So both x's and both lacking x's or any variables. And then down here we have again the definition of like terms. They're the same variables with the same exponents. So here they both have x, technically to the first powers. And note that x is different than x squared. Those are completely two different things. So you can't combine an x with an x squared. Those are different, different exponents that. And then the other thing we're going to do is always follow PEMDAS when we're simplifying. So here's a nice little review of this. And this is again from that same worksheet. P is for parentheses, working your way inner to outer. So start with the inside parentheses and then work your way to the outer ones. Exponents, multiply and divide, and again together left to right. D also stands for drop parentheses, and I'll show you an example of what I mean by that. And then if there's addition and subtraction, that'll be coming next, together left to right. So let's go through a couple of examples. I got the ones in blue that I want to do. So this should be in the next packet that you get. So our mission is to simplify each of these expressions. So number 2 here, we just got negative 6 minus 3y plus 19 minus 12. So this guy, negative 6, and this guy, negative 12, both are lacking a variable, so those guys would be like terms. So you can combine those together just by like adding, or in this case, like subtracting them straight up. Negative 6 minus 12. This is like you owe me $6, and you owe me 12 more bucks. Well, altogether you owe me 18 bucks. Maybe I'll do it in a different color here. And then here, these guys both have y's, right? So here we're talking about like yaks. Like you owe me 3 yaks, and now you look in your backyard, you got 19 yaks. Okay, so if you paid me those 3 yaks, you would still have about 16 yaks left over. Right, the other thing we got to be cautious about is the order. So in the future, moving forward, you always want to make sure you're writing the variables, the terms with variables first with the highest degree, which is like highest power, and then kind of work your way down. So technically, mathematicians would always like to write this like this. They'd always want the variables, the terms with the variables first, and then this is called the constant term. If it's got no variables, that would be written second. So next one, number 4 is kind of cool because they talk about different variables. So you can have a whole bunch of different variables. You just want to bring the ones that are together, ones that are the same together. Those are like terms. So this is like negative 20 g's and negative, this is technically like a negative 1 g right there, yeah? So if you owe me 20 goats and you owe me another 1 goat, well, you owe me 21 goats. Next, I can look at my h's. I got 14 hens, plus this is again like another 1. So 14 hens plus 1 hen is about 15 hens. There we go. And then the only other one I didn't hit on was the 9f. And there was no other f's in there, so that one would just stay as it is. Now, I mean, if you really wanted to, you could reorder these in like alphabetical order. putting that one first, but since there is no other powers here, I would be perfectly fine just leaving it like that. All right, I want to do one more on this page. Let's see here. So this is what I was talking about earlier, is that you see we got regular x's right here and right here, and then we got some x to the fourths, and then we have some x to the squareds. Well, you can only combine the ones that are the same together. So, and we always want to start with the highest one first. So I'm actually going to start with the green ones here. So both of these are x to the fourth. The number in front tells you how many of those you have. So we're doing negative 14 x to the fourth plus 4x to the fourth. Negative 14 plus 4 balances out to be like a negative 10. Like, you owe me 14 of these, you had 4 of them. If you paid me those 4, you still owe me 10 of those x to the fourths. So you treat the variables as if they are things like yaks and donkeys and oranges and all those other things I say. So here we're looking at the x to the fourths. Negative 14 plus 4 is negative 10. Next, we'll look at the x squareds because that's the next highest power. So we started with the 4s, so now we're going on. There were no 3s, but we got x squared here, and that's the only one, so that will just get recopied. And then lastly, we can deal with the blue ones together right here. So this is like 1x, take away 3x, or minus 3x. You'll get a negative 2x. And that 2 just looks funny. And again, this is good. All of my like terms, same variables, same exponents, are combined. The number in front, the coefficient, tells you how many you have. Let's see here. So now you get to problems that look like this. Now these ones are only different because they are in parentheses to begin with. So when you're thinking about order of operations, you're thinking about starting in those parentheses. Well, inside here I got g squared and I got g and I got nothing, no variables. So I can't combine a g squared with a g. Those are two different things. These are like gorillas, and these are like goats. They both start with G, but they're not the same thing, right? They got different spelling to them, G squared versus just G's. So inside we can't do anything here. Next we look at exponents. There are no exponents up here, so we can't do that. And then multiplication, division, there's nothing out front being multiplied or added in. So that D right here is standing for drop parentheses. We really don't need that parenthesis group surrounding this one. There's nothing we can do on the inside, and there's nothing affecting it on the outside. And we'd say the same thing over here. Inside, you can't combine those. Those are not the same. There's no exponents, and there's no number out front that's being multiplied in. Whoops. So really, I do not need I do not need those parentheses. I can drop those parentheses right there. So then from here, we're just combining like terms. So I'm going to start with the highest ones. I got some g squareds right here. 2 minus 11 is negative 9 g squared. That looks great. Here I got some regular g's, negative 14 and a negative 4, which will make a negative 18 g. And then lastly we got negative 11 plus 9, that's about minus 2. Whoopsies. Let's try that again. There we go. All right, combining like terms. There we go. And the last one I want to do looks like this. Now this is where it really actually has the only sort of real skill required, is because it's being subtracted. But I'm going to start off with PEMDAS. I'm going to look inside this first parenthesis group. I got b squared and I got b. Those are not like terms. This one doesn't have anything. There's no exponents and there's nothing up front. So for that first group, there is nothing acting on it at all. I can drop those parentheses. Now for the second group, there's nothing on the inside, there's no exponents on the outside, but this negative sign is affecting it. So the first way that I like to think about it is we are subtracting that group. So when you get those parentheses, you treat it all as a group. So if you're subtracting that group, that means you're subtracting every member inside of that group. So you're subtracting that 15b squared, you are subtracting that 19b, and you are subtracting that 8. All of those are being subtracted. Now, if you had it where there was a negative inside, subtracting a negative is adding a positive. So you might see that in a future problem, and that's fine. But from here we can keep going on. So now I'm going to combine all of my b squareds together. So I got 13 minus 15 is a negative 2b squared. I have a 20b and a minus 19b that ends up being like a 1b. If you just want to write b, that's fine. You don't need to write the 1. And then we got a 41 minus 8, what's that, about 33? and then that would be the end of that. All right, so you got a lot to practice. Make sure you just reach out if you have any questions, and we'll talk to you real soon.